Hello students, welcome to Jagannath Mathematics Tutorials. Today we are going to discuss KEAM 2024 Mathematics Solutions Part 2. In the previous Part 1 we have discussed 8 questions of this KEAM 2024. So we will begin from question number 9 here, right? You can go to this iTape and watch this part 1. So the first question is, let this is the greatest integer function, right? Let this be the greatest integer less than or equal to x, then limit x tending to 0 x greatest integer of x plus modulus of x whole divided by mod x is equal to, they are asking you, giving this 5 options, right? So how to approach this? See, you draw a number line and then see, here is your 0. Now x tending to 0 minus means from the left hand side, from the left hand limit, this will be LHL. So this function is, this x is approaching towards 0 from the left hand side, right? Now see, as x approaches to 0 minus, right, then your greatest integer function will be equal to minus 1. How? See here. This is the number line 0 minus 1 1. As x approaches towards 0, right, means x is between, x lies from zero or minus 1. So if x belongs to minus 1 comma 0, then greatest integer function of x will be equal to minus 1, means limit x tending to 0 minus greatest integer function of x is minus 1, right? I hope this is clear to all of you. Similarly, we have mod x. Now mod x is x when, if x is greater than equal to 0 and minus f, x if x is negative. Here x is negative as x approaches from the left hand side of the limit, right? Therefore mod x opens up to minus x as x is negative. Why? As x tends to 0 minus means left hand side part of the 0 is negative. I hope these things are clear to all of you. If you have any doubt, feel free to ask in the comment below, right? Now let's move on to this question. So the question was, what will be the value of this? This is equals to limit x tending to 0 x as it is. This will be mod x plus mod x upon mod x, right? This has to be changed. X tending to 0 minus, x tending to 0 minus. So x is as it is. X is as it is. This greatest integer function we have seen just now, limit x tending to 0 greatest integer function is equal to -1. Here will come -1, right? And for this mod x, as x is negative, then your mod x will be equals to -x from here, right? You can see this part. So here we place -x, whole divided by mod x means -x. This is equals to limit extending to 0 minus x -1 minus x upon -x. You take minus common, so this will be 1 plus x upon -x. Now this minus x gets cancelled out. You are left with limit extending to 0, 1 plus x, which is equals to 1 plus 0, which is equal to 1. So 1 is your right answer. Let's check the option. This will be option number D, right? Let's move on to this question. Given x equals to 5 tan t and y equals to 5 sec t, you need to find dy by dx at t equals to pi by 3, right? So see, x equals to 5 tan t. Name this as equation number 1. Now differentiating 1 with respect to t, with respect to the variable t, we get dx by dt is equals to 5 d by dt of tan t, right? This would imply that dx by dt is equals to 5 into derivative of tan t is what? Yes, that is secant square t, right? Similarly, you have y equals to 5 secant t. Name this as equation 2. Again, differentiating both sides with respect to t, you will get dy by dt equals to 5 times d by dt of sec t. Now the derivative of secant t is secant t times tan t, right? So we got this and got this as well. This is clear to all of you, right? Now next step is we want to find now dy by dx. Dy by dx is equals to dy by dt upon dx by dt, right? This implies dy by dx equals to, now dy by dt is 5 secant t into tan t. From here we get dy by dt, right? And from here we get dx by dt is equal to 5 secant square t. So we put this values in this. So this is 5 secant square t. So this 5 and 5 cancels out, this secant t and this secant t cancels out. So this will become dy by dx is equals to tan t by secant t, right? But in the question we are asked to find the value of dy by dx at the point t equals to pi by 3. So we have to put t equals to pi by 3. We put t equals to pi by 3 in the above equation. So we have dy by dx at the point t equals to pi by 3 equals to tan pi by 3 upon secant pi by 3. Right. Now you know the value of tan pi by 3, right? If you don't know, see here, tan pi by 3 is equals to root 3 and secant pi by 3 is equal to 1 by cos pi by 3, which is equals to 1 by half, which is equals to 2, right? So tan pi by 3 is equals to root 3 and secant pi by 3 is equal to 2, right? So we place this value over here. So we get dy by dx at the point t equals to pi by 3 equals to root 3 by 2. Let's check the option. This is option number C. I hope this question number 10 is clear to you. If you like this video, then do subscribe, share to your friends and all those future aspirants of KEAM who are preparing for the exam for the year 2025, right? Thank you for doing so. Let's read this question now. The area bounded by the curves y equals to x square and y equals to 2x in the first quadrant, right? So you know this is the first quadrant, right? So this blue line represents the equation y equals to 2x and this red line describes y equals to x square here, right? We need to find the area bounded by the curves y equals to x square and y equals to 2x in the first quadrant. Means this area we need to find, right? Is the question clear to everybody? Then we can move on to its solution. So given y equals to x square, now what should be the approach for this? The approach should be first to find the intersection point, means this point. It has two intersection points. So the first intersection point we know, this point is 0, 0, but we don't know this point. We have to find this point first, right? Now see, given y equals to x square and y equals to 2x, right? So we need to solve them. So equate 1 and 2, which means x square equate x square equals to 2x, which implies x square minus 2x equal to 0. Taking out x common, this will be x minus 2 equal to 0. So x equals to 0 and 2, right? Now when x equals to 0, y equals to 0, so we get the first intersection point as 0, 0. Now when x equals to 2, You can put 2 in any of this, in any of these equations. You can put x equals to 2 and you may see that y equals to 2. So we get our second point of intersection as 2 comma 2, right? So this point is 2 comma 2, right? And this point was the origin. So we need to find the area from 0, 0 to 2, 2 bounded by this two curves, y equals to x square and y equals to 2x. I hope the first step is clear to everyone. We need to find the point of intersection. Right. Now comes the area part. Now comes the area part. Now the area will be equal to, if you integrate it along dx, means integrate along dx. So this point is also 2. So this point is, sorry, this point is 0 to 2, right? So the integration will be from 0 to 2. See the first curve in the form of x. The first curve is this curve, right? Y equals to 2x is this. This is y equals to 2x and this is y equals to x square, right? So the upper curve minus lower curve. This will be 2x minus x square dx, right? Now next we need to just integrate it and find our solution. This will be equal to integration 0 to 2. You can integrate it like this only. From the property, this will be equals to 2x square by 2. This 2 cancels out, and this is from 0 to 2. This will be x cubed by 3, 0 to 2, right? So the area is equal to this x square 0 to 2 minus 1 by 3 x cube. So put the upper limit 2 square minus put the lower limit 0 square minus 1 by 3 put the upper limit 2 cube minus put the lower limit 0. This will be equal to 2 square is 4, right? So 4 minus 0 minus 1/3 2 cube is 8 minus 0. So this is equal to 4 minus 8 by 3. Area is equal to, take 3 as the LCM. This will be 12 minus 8 equals to 4 by 3. So the area comes out to be 4 by 3 square units. Let's check for the options. This is option number B. I hope this is clear to everyone. If you have any doubt, you may contact me through email provided in the description box. Now, next question, you need to integrate this function with respect to x. Now please comment how many of you have attempted this question, right? First you need to attempt this question and then see my solution. So let I is equals to integration secant x hold it upon sec x plus tan x whole square dx, right? This was our question. we need to we will multiply secant x plus tan x both on numerator and denominator, right? Then this integral will become like this. We are doing what here? We are multiplying the numerator by secant x plus tan x, and we are multiplying the denominator by secant x plus tan x, right? I hope this step is clear to everyone. Then our integration will be like this: secant x plus tan x dx whole divided by secant x plus tan x whole cube. I hope this step is clear to everybody, right? Now see, let secant x plus tan x equals to u. See, then we have derivative of secant x is secant x tan x, derivative of tan x is secant square x dx is equals to du, right? Now taking out secant x from this expression and from this expression, we get secant x tan x plus 1 secant x here dx is equals to du. Now can you see why we have taken this secant x plus tan x? See, secant x plus tan x dx is du, right? So our expression changes to integration this secant x times secant x plus tan x dx is du. So this numerator will be du divided by, in place of this, in place of secant x plus tan x, we have to put u, right? U, then cube, right? Don't miss this out, this cube. This changes to du by u cube, right? Next we integrate this. This will be u to the power minus 3 du, and we know integration of x to the power n dx is equals to x to the power n plus 1 upon n plus 1 plus c, right? This is plus c, where c is an arbitrary constant, and here n is not equal to minus 1, right? Because if if n is equal to a minus 1, then we have this formula, log mod x plus c, right? So this will be equals to u to the power minus 3 plus 1 by minus 3 plus 1 plus c. Next, this will be equal to u to the power minus 2 upon minus 2 plus c. Now in place of u, we will put secant x plus tan x. This will be equals to minus half secant x plus tan x whole to the power minus 2 plus c, or more precisely, we have this minus half. This will be equals to 1 over secant x plus tan x whole square. Why? As x to the power minus 2 is 1 by x square, right? This is from the laws of exponents. So this is our final answer is minus half secant x plus tan x whole square plus c. I hope this is clear to all of you. Let's see the option. I think this is option number B. This. If you have attempted this and got the right answer, then that's great from your side. Next question. If the integration of x e to the power minus x dx equals to m e to the power minus x plus c, where c is an arbitrary constant, then m is equal to what? This is again an easy question. We need to do first x e to the power minus x dx. This we know. This will be by parts question. This will be the first function. This will be the second function by Eilert rule, right? So let's solve this. So let I is equals to integration x e to the power minus x dx. Then we know this formula, integration u into v dx is equals to u integration v dx minus integration du by dx integration v dx whole dx. This is the formula for by parts, where u and v are functions of x. I hope all of you know this formula, right? I am highlighting this so that you can easily have a look at it. Right. This is the formula. Now this is our first function, means u. This is our second function. From this formula we have I equals to u, means x comes out. This will be integration v dx e to the power minus x dx minus integration of du by dx, right? Dx by dx integration e to the power minus x dx whole dx. This would imply that your integration is equal to, this is x. Now the integration of e to the power minus x is e to the power minus x by minus 1. How? See here. Integration e to the power ax dx is equals to e to the power ax by a, right, plus c. So here this was e to the power minus x dx is equal to the e to the power minus x by coefficient of x is minus 1, right? Minus integration dx by dx comes out to be 1. So this is 1, right? And e to the power minus x is again e to the power minus x by minus 1 dx. This implies I equals to this minus minus gets plus x e to the power minus x by this minus gets here. This will be minus x dx, which implies this will be minus x e to the power minus x. Now again the integration of e to the power minus x dx is e to the power minus x by minus 1, right? So this will be minus x plus c. On taking out common, this this e to the power minus x gets common from here, right? So we have I is equals to minus e to the power minus x. This will be x plus 1 plus c. Now we were given this I equals to m e to the power minus x plus c, right? See this, we were given I equals to m e to the power minus x plus c, right? Now you name this as equation 1 and you name this as equation number 2. Now compare, you will get m equals to minus of x plus 1, right? Let me write it again, minus of x plus 1. Let's check for the options. This will be minus of x plus 1. Option A is the correct answer. That's it for today. This will be your homework question. You may like, share and subscribe to this channel to get future updates. Share with your friends so that they can practice more and they can score well in their entrance exam. That's it from my side. Thank you all.